Okay, this is example 3 on page 3 of our unit 3 packet. It's a lot of threes. So this says a poll found that 38% of a random sample of 1,012 adults said they believe in ghosts. Check the necessary conditions for creating a confidence interval on the proportions. Okay, so the conditions were success, failure, the independence randomization, and the 10% condition. So we're going to start with the easiest one, which is independence / randomization. And I always quote the problem. So in this particular problem, we have a random sample. So this particular problem has randomization, which then implies, given if you saw my example from the video, that these are independent subjects. The second thing we want to do is check the success-failure condition. So this says I have at least 10 successes and at least 10 failures. And the only way to actually compute the number of successes is to figure out how many people said yes. So if 38% believe in ghosts out of 1,012 American adults, if we round what we get in our calculator to the closest number, we get 385 American adults who said yes or are considered successes. And this number is, in fact, bigger than 10. Then we would check that n minus x, or the number of people who said no, which is 1,012 minus 385, or 627, we also want to make sure that this number is bigger than 10, and that's correct, okay? Technically, these were greater than or equal to 10 if you want to go through and fill in those symbols, but that's not necessary. So far we've met the independence assumption and the randomization assumption. The independence and randomization and success failure. Our third question is this less than 10%? So is 1,012 less than 10% of American adults? And this would be, yes, a reasonable, that is absolutely true. There are millions of American adults. So 1,012 is definitely less than 10% of that particular population. Okay, now it says to compute a 90% confidence interval. All right. So this, so far, what we know is that this is also referred to as a one prop Z interval. Okay, this is what it is in our calculator. And it needs to be of our estimate of adults who believe in ghosts. So, in our calculator, we need X equals, N equals, and the confidence level. So the confidence level has to be added as a decimal. The total number of people surveyed is given in our problem. And we calculated X in order to check the success-failure condition. X is the same as N times P, which is, in this case, I should say approximately equal, but I'm still going to put the equal sign actually, 385. So we would go in our calculator and we would put 385, 1,012, and 0.9 into our one prop Z interval. So remember that you would want to go to stat, arrow right twice to tests, and it's option A. You have to arrow down quite a bit to get to option A, okay? So once we put that information in, we all get an output that is a confidence interval. It looks like this. So 0.3553 and 0.4055. What does this say? This says we are 90% confident the true proportion of American adults who believe in ghosts falls between 35.5% and 40.6%. That is what this says. We have only a sample, but because we met our three conditions, we can generalize this particular confidence interval about this entire population. And now it says that we want to find the margin of error if we want to be 90% confident in our estimate. So the way, and then it says just to use the answer from part B. So the easiest way to find the margin of error, which is what we're going to explain here in part D, the easiest way to find it is to use this equation. First find your confidence interval, right? So first you find your confidence interval, which is a lower bound and then an upper bound. And then you go into this equation. Take your upper bound, subtract your lower bound, and divide that difference by 2. So what does that look like for us? That looks like 0.4055 minus 0.3553, taking that difference and dividing it by 2. And we get 0.0251. So that's what our margin of error is. So what this says is the margin of error is always the extent to which our interval differs on either side of our sample proportion. So recall that our confidence interval, right, p hat is in the middle, and we move a little bit to the right by adding our margin of error, and we move to the left by subtracting our margin of error. So we end up with our interval that spans this little area here where the margin of error is a literal distance to the right or distance to the left, kind of like how we used the standard deviation as a measurement of distance. Now, using the idea from parts B and C, I think you could go ahead and compute the answers to parts E and F on the next page on your own. Good luck.